Assalamu alaikum. Welcome to Science Tutorial. In this tutorial, I'm going to explain how we can prove KCL and KVl, and how we can use potentiometer, and how we can use Y and delta circuit in multisim. At first, we are going to prove the first experiment, which is KCL and KVL. But before that, we need to know what is KCL and what is KVL. KCL states that Kirchhoff's current law, and at a point or at a junction, the entering current is equal to the sum of outgoing current. Here in this circuit, this point is the junction, and the entering current is Is, or incoming current is Is, and the outgoing current is I1, I2 and I3. If KCL states that Is equal to I1 plus I2 plus I3, and KVL, Kirchhoff's voltage law, while supply voltage is equal to summation of all drop voltage. Here, if Vs is the supply voltage, then V1 plus V2 plus V3 plus V4 plus V5 plus V6 is equal to Vs, and this is KVL. Now we are going to draw this circuit in multisim, and we are going to check Is, I1, I2, I3. Then we will add I1, I2, I3, and if I1, I2 and I3 summation is equal to Is, then it shows that incoming current is equal to outgoing current. At first, in multisim, we have to go place, then component, then sources or all group. Here we can search, or we can go sources, power sources, DC power, then we need to take some resistors, and we must go to basic, then resistor. I'm going to take one resistor, then I'm going to copy it and just paste it. Now I have to flip it or rotate it, then the second one, then the third one. Then I need some wire to connect. Then I need to change the resistor's value, and R3 is equal to 5.6 kilo ohm. Then R2 is 4.7 kilo ohm. R1 is 3.3 kilo ohm. And the supply voltage is 10 volt. Then we need to calculate current, and we need to take multimeter. We can determine current, voltage, and ohms resistance by multimeter. And we know that to determine current, we must connect it in series with resistor. And we know the shortcut to rotate, and that is Control R. Then I am going to connect all the multimeter in series. And I cannot connect this. We need to remove this, because if I don't remove that, then it won't show the real value. And here is our final circuit. Now I am going to run it. Here we need to get a ground. Then I am going to run it, and all the value is shown in the display. So this is I1, this is I2, this is I3, and all the value is 2.49, 2.49, 2.49. If I add all the value 2.49 to plus 49, 2.49, then that will be equal to 7.5. So now we can say that our experiment is done. Now I have to prove KVL. In order to prove KVL, I just need to draw this kind of circuit 2 again. And to do that, I am going to erase everything. Again, we will go to place component, resistor, I need to take 6 resistors and 1 voltage sources. DC power Here it is, and the value is 12 volt, and I also need to take a ground. So R1 is 1K, R2 is 10K, 10K, and I am going to rotate and R3 is 4.7K. So I just double click and the value is 4.7K and the R4 is 3.3 kilo ohm. R5 is 1K, so I don't need to change it, and R6 is also 1K, so I don't need to change it also. Now I want to press Ctrl R and rotate it by 90 degree. So again Ctrl R, then I just need to connect it with each connect this with multimeters, and I took 7 multimeter, and to determine voltage I have to connect it in parallel, because in parallel the voltage will be the same. So my circuit is done. Now I am going to run it, but before that I just need to take all of this. And I am done with these things. Now I am going to run this, and the voltage XMM1 is 2.538 volt, 9.46, 7.8, 1.9 millivolt. So if I add all of these things, then but before that I need to check one thing, that is XMM2. So I need to stop this and I just connect it in proper way. And still the total voltage is 12 volt. So here VR1 equal to 2.53 and VR2, I mean XMM3 is 9.462. If I add two voltages, then the Vs will be 12 volt. In XMM6, XMM5 is nearly 1.982 volt, and VR4 is 1.982 volt, and VR3 is 7.48. So if I add two voltages, then I will get 9.462, because in parallel connection we know that the voltage will be the same. So Here Vs equal to V1 plus V2 XMM3. So input supply voltage is equal to all drop voltages. So from this circuit we can say that our experiment or KVL is proved. Now I am going to do another experiment, and that is when we use potentiometer. So in order to do that, I just need to remove all of those things. So I am going to place component on voltage source. Then I need to take resistors, basic resistors, two resistors. Then I need to take on variable resistor, I mean potentiometer. In potentiometer we can vary the resistance value. So in order to get that all group, then I need to search it, and that is potentiometer rated. Here it is. Close, and I also need to take one ground. Then R2 is 560 ohm, 560, and R1 is the same value like R2. In potentiometer, here we can change the resistance value, and I have to give some information, and that is increment. We can change the increment rate, and I am giving 1%. And resistance here, if I get 10 kilo ohm, then it will be the maximum value of this resistance, and if we decrease the percentage, then we will get lower resistance value. And in this circuit I am going to take the maximum value is 10 ohm or 10 kilo ohm. So controller, again controller, and I have to here this is ground. I am going to take a multimeter, here it is, and in positive polarity I am going to connect with this arrow, and negative with this ground. Then I am going to take one more multimeter, then change the rotation to determine voltage. Here I am giving the input ohm for resistance value. Now I am going to run this, and if I change this, then I am going to get different voltages. So I need to stop this and change the value. Okay, done. Then I am again going to run it. Then we will get different voltages. If I just disconnect this, I'm going to disconnect it to only show the value of resistances, and I want to change the resistance value, and in this display you can see that if I change this, then the output resistance will be the different. So our another experiment is done, and our final experiment is on Y and delta conversion. So I'm going to prove that, and the circuit is here. It is, and I am going to draw this circuit, and to do that I need to remove this and again place component, sources, one DC source and 5 resistors, and on ground. So if you guys want to learn the basic or theoretical part of this thing, then you must visit our channel, and I will give the link in this tutorial's description. So all the resistances is 15 kilo ohm, So I'm going to connect it with each other. And our circuit is done. Then I'm going to take some multimeter and connect it in parallel to determine voltage. And we're done. Now I am going to run this circuit, and here this is the final output. And now this is 0 volt because of Western. So our experiment is done, and thanks for watching. If you like this video, then subscribe our channel, and to get more videos, subscribe Science Tutorial with Mahit and follow our Facebook page Science Tutorial.